everyone. Architecture, performance, and games. Before we plunge headfirst into a pile of patterns, I thought it might help to give you some context about how I think about software architecture and how it applies to games. It may help you understand the rest of this book better. If nothing else, when you get dragged into an argument about how terrible or awesome design patterns in software architecture are, it will give you some ammo to use. Note that I didn't presume which side you're taking in that fight. Like any arms dealer, I have wares for sale to all combatants. Chantilly, hello, good morning. We're going through the Game Programming Patterns book. It had been a while since I went through a book. The last one being the Rust book, so I'm looking forward to this. What is software architecture? This is actually an important question because there is a role, software architect, for programming in a lot of companies, and I think it's a super important role too. But I don't know if everybody defines it the same way. If you read this book cover to cover, you won't come away knowing the linear algebra behind 3D graphics or the calculus behind game physics. It won't show you how to alpha beta prune your AI search tree or simulate a room's reverberations in your audio playback. Reverberations of an entire room? That would be interesting. I love that he puts a note. Wow, this paragraph would make a terrible ad for this book. Instead, this book is about the code between all of that. It's less about writing code than it is about organizing it. Every program has some organization, even if it's just jam the whole thing into main and see what happens. So I think it's more interesting to talk about what makes for good organization. How do we tell a good architecture from a bad one? I think that's really important because that's sort of related to, hey, there's functions with 1,000 lines in them. Why is that bad? Is probably just as important as, well, how do I refactor this? I've been mulling over this question for about 5 years. Of course, like you, I have an intuition about good design. We've all suffered through code bases so bad, the best you could hope to do for them is take them out back and put them out of your misery. And sidebar, let's admit it, most of us are responsible for those. I am working in a code base at work right now that was written by contractors, and for the most part, it is that. A lucky few have had the opposite experience, a chance to work with beautifully designed code. The kind of code base that feels like a perfectly appointed luxury hotel festooned with concierges, waiting eagerly on your every whim. What is the difference between the two? Yeah, that's something I've struggled a lot because I've heard of good architecture, and I thought for a long time that's just clean code, right? That's just writing your code in a clean way will make it easy to update. But that hasn't panned out for me. I mean, it's better than not clean code. What is good architecture? For me, good design means that when I make a change, it's as if the entire program was crafted in anticipation of it. I can solve a task with just a few choice function calls that slot in perfectly, leaving not the slightest ripple on the placid surface of the code. That sounds pretty, but it's not exactly actionable. Just write your code so that changes don't disturb its placid surface. Right. Let me break that down a bit. The first key piece is that architecture is about change. Someone has to be modifying the code base. If no one is touching the code, whether because it's perfect and complete or so wretched that no one will sully their text editor with it, its design is irrelevant. The measure of a design is how easily it accommodates changes. With no changes, it's a runner who never leaves the starting line. This is actually something that I think we can maybe reuse legacy, like the word legacy for that. Legacy code bases are architectures that no longer change. I don't know if that's exactly true because we do go in and say, hey, we have to make changes to our legacy code base. But then is that really a legacy code base anymore if we're still updating that? I don't know. I would potentially argue that maybe we overuse the word legacy. How do you make a change? Before you can change the code to add a new feature, to fix a bug, or for whatever reason caused you to fire up your editor, you have to understand what the existing code is doing. You don't have to know the entire program, of course, but you have to load up all of the relevant pieces of it into your primate brain. It's weird to think that this is literally an OCR process too. I mean, there is that sort of like theory that our brain is kind of like a computer. We tend to gloss over this step, but it's often the most time-consuming part of programming. If you think paging some data from disk into RAM is slow, thank you, Dark Sky, for letting me know that it is 53 degrees outside. Where was I? Okay, we tend to gloss over this step, but it's often the most time-consuming part of programming. If you think paging some data from disk into RAM is slow, try paging it into a simian cerebrum over a pair of optical nerves. Once you've got all the right context into your wetware, you think for a bit and figure out your solution. There can be a lot of back and forth here, but often this is a relatively straightforward process. Once you understand the problem and the parts of the code it touches, the actual coding is sometimes trivial. Yeah, that's sort of like, this is a problem that I see junior developers. I mean, it happens to everyone, but like when I was teaching, it happened to junior developers the most often, which is, oh, you have a problem? Here's an existing code base. And I come back like half an hour later and they're coding. They haven't like actually read through the problem yet. They don't understand the code base. They don't understand what they're doing even. They're just coding right away. And I think like taking the time to understand what the problem really is really important. You beat your meaty fingers on the keyboard for a while until the right colored lights blink on screen and you're done, right? Not just yet. Before you write tests and send off your code for review, you have to do some cleanup. You jammed a bit more code into your game, but you don't want the next person to come along to trip over the wrinkles you left throughout the source. Unless the change is minor, there's usually a bit of reorganization to do to make your new code integrate seamlessly with the rest of the program. If you do it right, the next person to come along won't be able to tell when any line of code was written. In short, the flow for programming is something like get a problem, learn code, code the solution, and clean up. Which this is actually a lot, like this is similar to, not exactly the red-green programming in agile development, which is test-driven also. Sidebar, did I say tests? Oh, yes, I did. It's hard to write unit tests for some game code, but a large fraction of the code base is perfectly testable. I won't get on a soapbox here, but I'll ask you to consider doing more automated testing if you aren't already. Don't you have better things to do than manually validate stuff over and over? The fact that there is no escape from that loop is a little bit alarming now that he thinks about it. I mean, that is true. There's like, it's a loop. It just goes on forever. How can decoupling help? While it isn't obvious, I think much of software architecture is about that learning phase. Loading code into neurons is so painfully slow that it pays to find strategies to reduce the volume of it. This book has an entire section on decoupling patterns, and a large chunk of design patterns is about the same idea. You can define decoupling a bunch of ways, but I think if two pieces of code are coupled, it means you can't understand one without understanding the other. If you decouple them, you can reason about either side independently. That's great, because if only one of those pieces is relevant to your problem, you just need to load it into your monkey brain and not the other half too. To me, this is a key goal of software architecture. Minimize the amount of knowledge you need to have in cranium before you can make progress. The later stages come into play too, of course. Another definition of decoupling is that a change to one piece of code doesn't necessitate a change to another. We obviously need to change something, but the less coupling we have, the less that change ripples throughout the rest of the game. This is a super, super common problem, not just in game development, in like just all software development, especially monolithic applications. I've seen where we made a change in like one area and like a completely different section of the app breaks, and you have no idea why, but it turns out that the class that you're updating just happens to be pulled in by another class that's pulled in by another class that's pulled in by another class, and there's no way to know that until your regression tests break. And if you don't have regression tests, then you won't know it's broken until users complain about it, if they complain about it. At what cost? This sounds great, right? Decouple everything, and you'll be able to code like the wind. Each change will mean touching only one or two select methods, and you can dance across the surface of the codebase, leaving nary a shadow. This feeling is exactly why people get excited about abstraction, modularity, design patterns, and software architecture. A well-architected program really is a joyful experience to work in, and everyone loves being more productive. Good architecture makes a huge difference in productivity. It's hard to overstate how profound an effect it can have. But, like all things in life, it doesn't come free. Good architecture takes real effort and discipline. Every time you make a change or implement a feature, you have to work hard to integrate it gracefully into the rest of the program. You have to take great care to both organize the code well and keep it organized throughout the thousands of little changes that make up a development cycle. You have to think about which parts of the program should be decoupled and introduce abstractions at those points. Likewise, you have to determine where extensibility should be engineered in so future changes are easier to make. People get really excited about this. They envision future developers, or just their future self, stepping into the codebase and finding it open-ended, powerful, and just beckoning to be extended. They imagine the one game engine to rule them all. The second half of this, maintaining your design, deserves special attention. I've seen many programs start out beautifully and then die a death of 1,000 cuts as programmers add just one tiny little hack over and over again. Like gardening, it's not enough to put in new plants. You must also weed and prune. So my own thought on top of that, because I do agree that I've seen that quite a bit. Usually it's a solo developer who begins a project for a company or for themselves. The architecture is good. It's easy because it's their own headspace. It's for themselves. But then this becomes a group project. It becomes multiple developers working together. And if all of the developers aren't aligned on like the business needs and the whys of this code base and like the customers and who's it solving, it's really easy to like just not care. It's sort of like, oh, we're going to a hotel. It's not our house. I don't need to take care of it. Somebody else will is in charge of like the architecture of this. I'm just doing my job of adding this feature. And I've also seen management be blamed quite a bit. Of course, there are some bad managers out there who will just say like, yeah, just add it. I don't really care about technical debt. But most managers I know are terrified of technical debt. Probably because it's used as a it's used as the excuse of why features can't be added, and most people have been in a failed like startup these days that may have failed because of technical debt. So it is something that managers, non-technical managers, actually are aware of, and the metaphor isn't terrible. But I think that this is somewhere where like we need to together, like as teams, come together, make sure that we are not just throwing things into our code base and then not cleaning up. But this is where it starts to get tricky. Whenever you add a layer of abstraction or a place where extensibility is supported, you're speculating that you will need that flexibility later. You're adding code and complexity to your game that takes time to develop, debug, and maintain. Features that can't be added or will take much longer to add to the feature. Yeah. That effort pays off if you guess right and end up touching that code later. But predicting the future is hard. When that modularity doesn't end up being helpful, it quickly becomes actively harmful. After all, it is more code you have to deal with. When people get overzealous about this, you get a code base whose architecture has spiraled out of control. You've got interfaces and abstractions everywhere, plugin systems, abstract base classes, virtual methods galore, and all sorts of extension points. Some folks coined the term Yakhni. You aren't going to need it as a mantra to use to fight this urge to speculate about what your future self may want. I see this in the code base I work all the time. Specifically, it's things like, well, what if, because as soon as you play the what if game, like it's over. What if my manager is gonna ask me to change this feature to work in this completely different way? Well, if he does that, then I'm gonna need to refactor in this way. So they're almost playing like they're like basically blaming a manager before like any managers even come up and ask for like different features, and they just on their own go out and like add all these like they're trying to be flexible. That's what they're really trying to do. But flexibility doesn't happen in the code base. Flexibility happens at a team level. That's what Agile is all about. It takes you forever to trace through all that scaffolding to find some real code that does something. When you need to make a change, sure, there's probably an interface there to help, but good luck finding it. In theory, all of this decoupling means you have less code to understand before you can extend it, but the layers of abstraction themselves end up filling your mental scratch disk. Code bases like this are what turn people against software architecture, and design patterns in particular. It's easy to get so wrapped up in the code itself that you lose sight of the fact that you're trying to ship a game. The siren song of extensibility sucks in countless developers who spend years working on an engine without ever figuring out what it's an engine for. I think this goes back to the entire problem where people will start programming before really understanding, especially when we talk about the business space. Because sometimes we say like, hey, as a developer, I don't want to worry about the business stuff. Tell me what to do and then I'll do it. But if we don't understand the why, like the customer space and the needs, we're never going to build the right thing. It's just going to be the wrong thing, or the architecture is going to be bad. Performance and speed. There's another critical critique of software architecture and abstraction that you hear sometimes, especially in game development, that it hurts your game's performance. Many patterns that make your code flexible rely on virtual dispatch, interfaces, pointers, messages, and other mechanisms that all have at least some runtime cost. There's a reason for this. A lot of software architecture is about making your program more flexible. It's about making it take less effort to change it. That means encoding fewer assumptions in the program. You use interfaces that your code works with any class that implements it, instead of just the one that does today. You use observers and messaging to let two parts of the game talk to each other, so that tomorrow it can be easier to be 3 or 4. But performance is all about assumptions. The practice of optimization thrives on concrete limitations. Can we safely assume that we'll never have more than 256 enemies? Great, we can pack an ID into a single byte. Will we only call a method on one concrete type here? Good, we can statically dispatch or inline it. Are all of the entities going to be the same class? Great, we can make a nice contiguous array of them. This doesn't mean flexibility is bad, though. It lets us change our game quickly, and development speed is absolutely vital for getting to a fun experience. No one, not even Will Wright, can come up with a balanced game design on paper. It demands iteration and experimentation. Does everyone know who Will Wright is? He was Maxis's founder, right? For like The Sims, SimCity, all those games. But I don't know if that's like a common knowledge anymore since Maxis was bought by EA. It was EA, right? It wasn't I think it was EA, not Activision. Sometimes like all those like the really big game companies, I mix them all together, and it's hard to like remember which one's which. One interesting counterexample is templates in C++. Template metaprogramming can sometimes give you the abstraction of interfaces without any penalty at runtime. There's a spectrum of flexibility here. When you write code to call a concrete method on some class, you're fixing that class at author time. You've hard-coded which class you call into. When you go through a virtual method or interface, the class gets called isn't known until runtime. That's much more flexible, but implies some runtime overhead. Template metaprogramming is somewhere between the two. There, you make the decision of which class to call at compile time when the template is instantiated. I'm actually really curious to like see how this would be in Rust programming too, because Rust, the compiler is getting really good at basically being more efficient. The release is making everything really, really fast. The release version. Mode? Flag? The faster you can try out ideas and see how they feel, the more you can try and the more likely you are to find something great. Even after you've found the right mechanics, you need plenty of time for tuning. A tiny imbalance can wreck the fun of a game. There's no easy answer here. Making your program more flexible so you can prototype faster will have some performance cost. Likewise, optimizing your code will make it less flexible. My experience, though, is that it's easier to make a fun game fast than it is to make a fast game fun. One compromise is to keep the code flexible until the design settles down, and then tear out some of the abstraction later to improve your performance. This, I believe, is only possible if we have testing in place. Because if you have testing, then you'll be able to refactor with confidence. If you don't have testing, if you tear out some like classes and like make the code more procedural or do something else, then like how do you know that you didn't break some weird part that nobody looks at except all of your users, all of your players that like they somehow managed to find it. The good and bad code. That brings me to the next point, which is that there's a time and place for different styles of coding. Much of this book is about making maintainable, clean code, so my allegiance is pretty clearly to doing the things the right way. But there's value in slapdash code too. Writing well-architected code takes careful thought, and that translates to time. More so, maintaining a good architecture over the life of a project takes a lot of effort. You have to treat your codebase like a good camper does their campsite. Always try to leave it a little better than you found it. This is good when you're going to be living in and working on that code for a long time. But, like I mentioned earlier, game design requires a lot of experimentation and exploration, especially early on. It's common to write code that you know you'll throw away. If you just want to find out if some gameplay idea plays right at all, architecting it beautifully means burning more time before you actually get it on screen and get some feedback. If it ends up not working, that time spent making the code elegant goes to waste when you delete it. Prototyping, slapping together code that's just barely functional enough to answer a design question, is a perfectly legitimate programming practice. There's a very large caveat though. If you write throwaway code, you must ensure you're able to throw it away. I've seen bad managers play this game time and time again. From the boss. Hey, we got this idea that we want to try out. Just a prototype, so don't feel like you need to do it right. How quickly could you slap together something? The dev. Well, if I cut lots of corners, don't test it, don't document it, and it has tons of bugs, I can give you some temp code in a few days. Great. Cut to a few days later. Boss, hey, that prototype is great. Can you just spend a few hours cleaning up a bit now, and then we'll just call it the real thing? Yeah. Let me finish this last paragraph, and then I'll give my thoughts on this. You need to make sure the people using the throwaway code understand that even though it kind of looks like it works, it cannot be maintained and must be rewritten. If there's a chance you'll end up having to keep it around, you may have to defensively write it as well. One trick to ensuring your prototype code isn't obliged to become real code is to write it in a language different from the one your game uses. That way, you have to rewrite it before it can end up in your actual game. That's actually a brilliant idea there. So I think what this example is highlighting here is a common miscommunication, like sort of like misunderstanding of between like management and dev. And it's this gap of communication that like causes problems. And I think that the natural inclination of us devs is to like back away from management and like put up more barriers, like put up process and barriers and other things that we can't be asked to implement this code right. But now sort of all like, you know, full I forgot the word. Full disclosure here, I am a manager, I'm a team lead, and I have developers working with me. But something that I have realized, even before I became a manager, is that this will always happen over and over and over again. And the reason why it happens is because you can't afford as a business to not be selling things. There's too many obligations, and not just to stakeholders, like to being able to pay for payroll, for example. So, an example: if I worked at a company, we had in the past we had a product. It really badly needed a rewrite. But if we were to take the time to rewrite it, it would have taken about maybe a year, maybe a year and a half, possibly 2 years to like do the full rewrite. In that time, we would not be able to sell new features. We would not be able to get new clients essentially because we were just basically maintaining clients. But also, we wouldn't be bug fixing any of like the existing code because we didn't have developers for that. So without maintaining and without like doing something with that terrible code, we would essentially be hemorrhaging money. We wouldn't last that long. Most companies don't have multiple years of money in their bank accounts, especially startups who, usually have around a year, and that's with sales happening at the same time. They're just always sort of like on that brink of collapsing. So it's as soon as we as developers realize that, this is like, no, like, okay, as a dev, if I understand that it's like another question. So here's what I would put into it. Hey, are we actually providing this to clients? Oh yeah, we're gonna be showing it to clients. We're gonna be like adding it into our demo and selling it. It's like, great, okay, now I know the use case of this, what the value add of this code is gonna be. I am definitely going to write it defensively. I mean, that's just the only answer there. Striking a balance. We have a few forces in play. We want nice architecture so that code is easier to understand over the lifetime of the project. We want fast runtime performance, and we want to get today's features done quickly. I think it's interesting that these are all about some kind of speed. Our long-term development speed, the game's execution speed, and our short-term development speed. These goals are at least partially in opposition. Good architecture improves productivity over the long term, but maintaining it means every change requires a little bit more effort to keep things clean. The implementation that's quickest to write is rarely the quickest to run. Instead, optimization takes significant engineering time. Once it's done, it tends to calcify the codebase. Highly optimized code is inflexible and very difficult to change. There's always pressure to get today's work done today and worry about everything else tomorrow. But if we cram in features as quickly as we can, our code base will become a mess of hacks, bugs, and inconsistencies that saps our future productivity. There's no simple answer here, just trade-offs. From the email I get, this disheartens a lot of people, especially for novices who just want to make a game. It's intimidating to hear there's no right answer, just different flavors of wrong. But to me, this is exciting. Look at any field that people dedicate careers to mastering, and in the center you will always find a set of intertwined constraints. After all, if there was an easy answer, everyone would just do that. A field you can master in a week is ultimately boring. You don't hear of someone's distinguished career in ditch digging. He has a sidebar here. Maybe you do. I didn't research that analogy. For all I know, there could be avid ditch digging hobbyists, ditch digging conventions, and a whole subculture around it. Who am I to judge? To me, this has much in common with games themselves. A game like chess can never be mastered because all of the pieces are so perfectly balanced against one another. This means you can spend your life exploring the vast space of viable strategies. A poorly designed game collapses to the one winning tactic played over and over until you get bored and quit. And then we have simplicity. Lately, I feel like if there's any method that eases these constraints, it's simplicity. In my code today, I try very hard to write the cleanest, most direct solution to the problem. The kind of code where after you read it, you understand exactly what it does and can't imagine any other possible solution. I aim to get the data structures and algorithms right, in about that order, and then go from there. If I find if I can keep things simple, there's less code overall. That means less code to load into my head in order to change it. It often runs fast because there's simply not as much overhead and not much code to execute. This certainly isn't always the case though. You can pack a lot of looping and recursion into a tiny amount of code. However, note that I'm not saying simple code takes less time to write. You'd think it would since you end up with less total code, but a good solution isn't an accretion of code. It's a distillation of it. Blaise Pascal famously ended a letter with, "I would have written a shorter letter, but I did not have the time." I think that was something like multiple pages in that quote. Another choice quote comes from Antoine de Saint-Exupéry. I don't know how to pronounce French names. Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. Closer to home, I'll note that every time I revise a chapter in his book, it gets shorter. Some chapters are tightened by 20% by the time they're done. We're rarely presented with an elegant problem. Instead, it's a pile of use cases. You want the X to do Y when Z, but W when A, and so on. In other words, a long list of different example behaviors. The solution that takes the least mental effort is to just code up those use cases one at a time. If you look at novice programmers, that's what they often do. They churn out reams of conditional logic for each case that popped into their head. But there's nothing elegant in that, and code in that style tends to fall over when presented with input even slightly different than the examples the coder considered. When we think of elegant solutions, what we often have in mind is a general one, a small bit of logic that still correctly covers a large space of use cases. Finding that is a bit like pattern matching or solving a puzzle. It takes effort to see through the scattering of example use cases to find the hidden order underlying them all. It's a great feeling when you pull it off. Sometimes you might find devs who who will proudly say, and very aptly too, I was able to delete 10,000 lines of code today because we made like this one small change. Well, that's what they're talking about here. They simplified the code that maybe was like a complexity. Ironically, some things that we might think are simple, like if-else statements, are actually complexity. There is something called cyclomatic complexity in code, which is the number of pathways that the runtime can go through, and an if statement increases that cyclomatic complexity. Get on with it already. Almost everyone skips the introductory chapters, so I congratulate you on making it this far. I don't have much in return for your patience, but I'll offer up a few bits of advice that I hope may be useful to you. Abstraction and decoupling make evolving your program faster and easier, but don't waste time doing them unless you're confident the code in question needs that flexibility. Think about and design for performance throughout your development cycle, but put off the low-level nitty-gritty optimizations that lock assumptions into your code until as late as possible. Trust me, 2 months before shipping is not when you want to start worrying about that nagging little game only runs at 1 frames per second problem. Move quickly to explore your game's design space, but don't go so fast that you leave a mess behind you. You'll have to live with it, after all. If you're going to ditch code, don't waste time making it pretty. Rockstars trash hotel rooms because they know they're going to check out the next day. But most of all, if you want to make something fun, have fun making it. Yes, I agree with everything about this. I think it's all like very, very, very apt. Like maybe one thing to add on here is compilers are getting better and better and better all the time. Specifically, if you program with best practices, and best practices are actually more about the architecture of the code and clean code, not about like bare metal, like, oh, the we have to use for loops because recursion is just like it's microseconds slower. The compilers will actually change things into their appropriate like form before it puts them into the binaries or runs them. JavaScript is a great example of this. It used to be super, super slow. Now it's super, super, super fast because it goes through these optimizations that are just amazing when you look at what they do.